This is an open discussion about the AHUs. I'm working in a pharmaceutical industry, but I have a big experience in the commercial area as well. Unlike the air handling units used in a commercial environment, the ones used in the pharmaceutical industry are a little bit different. The relative humidity, the temperature, and the air pressure are better monitored, but it makes sense because the medication can kill people. So just imagine, especially where I'm working, they are making vaccines, and because they do this, a vaccine can go straight in the bloodstream, and it can create a lot of hazard in someone's blood inside. So as you see, this AHU have this extract recirculating airflow, and the supply airflow, they are driven by two motors, and in case one of these motors will have an electrical fault, the programmable logic control will stop that motor and it will start the other one within 3 minutes. Otherwise the room must be cleaned for 3 days and the production will stop, and then there will be a lot of money loss. So I'm sure you're familiar with the extract and supply fan. You see the one you see now surrounded is just a supply fan. This is the fresh air intake, and what you just see now, it is the frost heat exchanger, the primary filter, the primary cooling coil. This is only for the fresh air intake, and this is the damper which allow more or less fresh air to come into the system. This is the recirculating damper which works against the fresh air damper, and this is the air mixing chamber where the recirculated and fresh air meet. This is the secondary filter, and this is the main cooling coil. It cools both recirculated and fresh air. This is the heat exchanger, and this is the humidifier. What you'll see now surrounded by red circle, it is the exhaust air damper, and this is the supply air duct. The red dots represent actuators. They are controlled by the programmable logic control. They are proportional. They're not 0 and 1. They can go from 1% to 100%. That yellow arrow you see, it's a return, it's a fresh air intake. If that is green and it's okay, there's no blockage, you start checking the dampers and the heat exchangers one by one. You check the actuators to see if they're okay. You check if enough fluid goes through the heat exchangers so you will not have any blockage. And you do this for all heat exchangers, for all actuators. You check the VSDs and the motors. And once you finish this, you'll connect everything to the PLC. You can connect this before to the PLC and to check them through PLC if you want. It doesn't matter. So if everything is okay, you start putting into the system probes. Across the filters, you'll put differential pressure filters, analog, connected to the PLC, so you can read the filter contamination level. Into the ducts, you'll put pressure switches, air volume probes, and also you'll put relative humidity and temperature probes. You have to control the air pressure, the air volume, and also the temperature and the relative humidity. Then you can start the system. Once you will connect all probes to the PLC you now have the capability to collect data and then to manipulate these actuators. You'll open the dampers, you'll start the supply and extract fan. As you'll see here, you just recirculating the air, and now you satisfy every single pressure switch and differential pressure switch and the air volume probes. It's all good. Everything works well. If outside is very hot, you will start the pre-cooling coil, which will cool the fresh air. The recirculated air is still warm because it takes a while until the room cools down. And the cooling coil will be started as well. And the air, step by step, start to cool down. And the room start to cool down, but it will take a while. Once the temperature is reached, the relative humidity and the temperature probe should change green. That means you have a perfect condition. In case of relative humidity goes too high, you will use the heater against the cooler to balance the capacity that way, so you can run the cooler mode to remove the absolute humidity. And all these little heat exchangers will be used against each other to have a perfect control, not only in temperature but also in humidity. You will see further down the line that some technicians have this atrocious pleasure to ignore the automatic control and to manipulate these actuators manually, having a great results for very short period of time, sometime hours, sometime minutes, sometime maybe days. This is a very dangerous, because the PLC monitor the system every second. As you will see, it is even hard for me to talk now in this virtual world and to follow how many changes a PLC does to the system to control the humidity, the temperature, and obviously the air volume. Now let's talk a little bit about the HEPA filters, because this AHU provides it through some normal filters, but again, it's a special environment. So every AHU duct, it is provided, every outlet, it is provided with the HEPA filters. The HEPA filters retain 99.97 of little parts that passes by through an ordinary filter. So while the air passes by the way you see, it's recirculating through the system, brought back in the mixing chamber, meeting with the fresh air, coming back. As long as the filter are okay, it's all good. But if the filter get red, then it's an alarm. An imperfect system without the differential pressure switch across the HEPA filter will not work well. The main sensor into the duct will send the BMS an input telling me is not enough air flow to the duct, and will sacrifice the filters by increasing the pressure into the system. I'll speak about this later on. One of the other biggest dangers, if you increase the fan speed, supply fan, you can increase the airflow might start to come back through the exhaust. And you look at that section, you will bypass the primary cooling coil, the frost, and the primary filter. On the right hand side you see different cross-section area for the filters. Even if some of them are small, they can push the same volume by increasing the pressure. But if you do not respect the HEPA filter maximum pressure allowed by the manufacturer, you will force more bacteria to that filter, and their efficiency will be nothing. What you will see here, this is the way the air should work. This is the only way the air should be circulated by an AHU. The fresh air will come only through the fresh air intake, and the exhaust will only allow the air to go out. If everything works like this, it's perfect. But if you're unlucky enough to have this is bad. When the air comes back through the exhaust, that's very bad, because that air bypasses the frost heat exchanger, the primary filter, and the primary cooling coil, so you will not have any control. I call it dirty air, which gives us a lot of headache. So that's not good. What you see in this picture should not happen. Unfortunately, sometimes it does happen. So you only have to look into the system to have this condition, so the air circulate that way. And what you will see now here, all these lights are changing. Every single heat exchanger, it is activated or deactivated. The PLC is monitoring constantly the air quality, applying that data against the software and controlling the actuator to have a constant airflow, temperature, and relative humidity. A human being cannot do that. That's an illusion. So I will provide you with more videos in the future. I'm sorry for my mistakes, but it's all I can do at the moment. Thank you.